Hi, it's iFell3 here. Now I brought this little stove that comes with the pot stand and it had two different levels. Well, it had one level, but I thought I could test the temperature difference between the bottom level and the top level. So how this was designed, out of the factory, the stove sits about 35mm underneath the pot. Placing the alcohol burner at the bottom adds about another 32mm of heat flame travel to reach the bottom of the pot. The first test I did at 136 grams total for the stove to bring to the boil took 15 minutes and 40 seconds. When I'd done the same test with 123 grams total weight of the stove, it took 11 minutes 55 seconds. That's nearly a whole 4 minutes quicker with less fuel. Now when I topped the stove back up to 136 grams total weight of the stove, placed at the bottom, took 13 minutes and 13 seconds. This was nearly a minute slower than what it did when the stove was at 123 grams. This led me down to the rabbit hole of thinking, what would happen if you topped up the stove to the max, all the way down to about 30 mils of alcohol? These are going to be the tests. There's a lot of figures, but at the end, I've produced a graph. Also, bear in mind that this is pure alcohol, not methylated spirits, that sometimes the stove being underneath the pot will help reflect some of the heat down, heating up the stove to bloom quicker. These measurements are for full bloom. No messing around, no chugging, no chuffing of the jets, a proper full bloom. Now this is the English Woodsman video when he was comparing his real Trangia with a knockoff Trangia. He said in there it took about 2 to 3 minutes for it to reach bloom.
A second or two. Right, so 2 minutes in, the original stove is starting to bloom around the edges. My one, it is starting to flicker a little bit from top.
Just a note, I don't think his bloom time was in the same regards that I class my full bloom time. No chuffing, like I said, a good old flame in the middle, peaking up to the top. Now before you say, oh, it's not a real Trangia stove, yada yada yada, go and check out the Paleo Hikers MD channel.
Interesting, because they appear to be basically the same thing. Is the Esbit or the Solo stove worth more money? No, I really don't think so. If you want to save a little money off the Trangia and get something cheaper.
So to work out my calculations, 30 mils of my alcohol fuel weighs 23.85 grams. 23.85 divided between 30 equals 0.795 mils for 1 milliliter of fuel. My stove, dry, weighs 53.6 grams. I then went on to the calculatorsite.com, conversions, substances, petrol. In there you can enter your density of the fuel you'd like to measure. I've put the density 0.795 grams per milliliter. I'm now converting from grams to milliliters. I would enter in the weight of the combined stove and fuel minus the stove, which gave me the milliliters I was using, roughly. Maybe, give or take, a milliliter here or there. So as you can see, I've done a quick test with the temperatures of the fuel and weighed the stove. So this grid may be a bit confusing with all these numbers coming up, but feel free to pause the video. You could probably zoom into the little square just to make sure there's no trickery going on, like I am doing this for myself. And I thought I'll just share the information just so other people are aware that the more you fill up the Trangia, obviously there is more fuel to heat up before it then can start evaporating to reach its full bloom temperature. I've all pretty much started these at the same time with the flick of the lighter using modern technology and video editing. In some of these tests, the fuel and the stove was a little bit more cooler. The ambient temperature might have been a little bit more warmer. I've been trying to get it roughly within 4 degrees Celsius here and there. This video is obviously speeded up. It seems to be a sweet point, I would say, of possibly under 50 milliliters of fuel in the stove before the bloom time really starts to drag on and it not becoming worth your time. One of the other reasons I'm doing this, if you have a job where you just want a warm cup of tea, some hot water to rehydrate your food, or if you're like myself, possibly contemplating van life, and in the mornings you don't want to be messing around with no gas, no electric, you just want to put your mug on top of a stove in the sink just for a cup of coffee. There's no messing around with a stove that you have to empty your fuel. You can just put the lid back on and off you go. Some of the results have come in a bit odd, but give it a second because I've took all the data, I've put it onto an Excel sheet and I've made a scatter graph. So here we go. As you can see, from the time on the left to the millilitres in the stove at the bottom, there is a kind of curve that you can see, give or take a few here and there. I don't know what that's about. Maybe the temperatures are a little bit higher or lower, but you can see there's definitely a curve. Once you start going above 40 millilitres, your time starts picking up. Anything around 60 millilitres, you're looking for around about a 4 or 5 minute time before it starts to really bloom. All the way up to about 98 millilitres, I think it was, is pushing about 9 minutes before it really come up to a bloom. Now what this is the fuel inside the stove has to heat up to a certain temperature before it becomes a vapour, before it then starts to, let's say, ignite the jets and reach a bloom time. Part 2 is actually going to be the review of it. I'm going to be looking a bit more into the stove as a general review. So don't forget to subscribe, hit the bell button for notifications when I do the part 2 of that video. Or if you're watching this in the future, I'll probably put a link at the bottom. I feel free over and out.